on this project is focused on sine functions. We're going to learn what are they, how we can solve equations, etc. The thing is that we already know how to, but we don't remember seeing as we saw that last partials. So what we have as a purpose on this project is to remember, to actually study for our final exam, but to learn more characteristics of sine functions that can be fun, and for us to further know this information. Something really important about this project is that we're going to analyze real-life applications and we're going to solve a problem so that we actually practice what we have seen and what we have investigated. So, as we can see, this is a basic sine graph. It begins and it is increasing, so it looks like a wave that goes up, down, and then up again. We will later see the period, but it is 2 pi because that's what it takes for there to be one consecutive round that later repeats itself. So it goes up, down, and then when it will go up again, it starts another period. So the same graph, just the basic one, which is sine x, starts at 0, goes up to 1, and goes down to -1. This is why we know that the range is going to be -1 to 1, but that domain is -infinity to infinity, because as we can see, there is no limit. The sine function represents sine waves, or sinusoidal waves, because as we can see, it repeats itself along the x-axis without stopping. It goes through cycles, as I explained, and these are called the period. This is why it's 2 pi.
This is the graph of sine, and the sine graph is called a periodic function because it repeats itself with intervals that are called periods. The graph of pi has a period of 2 pi because each period covers 2 pi units. We know that the equation of a sine function is y equals a sine bx minus c plus d, where a is the amplitude, b is the value that will help us find the period, c is our horizontal shift, and d is our vertical shift. Therefore, in the equation y equals 1 minus 3 sine x over 2 plus pi, we know that 1 is going to be our vertical shift, 3 is going to be our amplitude, 1 over 2 is the value that will help us find the period, and pi is our horizontal shift. And this negative is telling us that there will be a reflection on the x-axis, so we'll have to remember that. So first, our amplitude is 3, because 3 is a. Then our period is 2 pi over b, where b here is 1 over 2. Therefore, our period is 4 pi. Our endpoints, we can know that our first endpoint is x over 2 plus pi equals 0. Therefore, x is going to be equals to -2 pi. So we know that our first endpoint is going to be at -2 pi, comma, 1, because our vertical shift is of 1 unit. And our other endpoint is going to be x over 2 plus pi equals 2 pi. Therefore, x is going to be equal to 2 pi. So our second endpoint is going to be 2 pi, comma, 1. So now that we have our endpoint, our amplitude, and our period, we can start graphing. Our first endpoint is here at -2 pi, comma, 1. And our other endpoint is at 2 pi, comma, 1. So we need to find 3 points to build our graph. So we know that our second point is going to be, we're going to go down because we have a negative. That means a reflection over the x-axis. So due to the amplitude that is 3, as we can see here, we'll have to go here and then 3 down. 1, 2, 3. So our point will be here. Our next point is going to be right here in the middle. And our third point, it's going to be 3 units up due to the amplitude. 1, 2, 3, and on the next. Therefore, our graph will look like this. So, now that we have the graph, we know that our average y value, which is the value in the middle, is y equals 1. That our domain is from -2 pi to 2 pi. Our range is from -2 to 4. And that's it.
Okay, so I'm going to do problem number 5. The average human body temperature throughout the day can be modeled using a sine curve. Susan recorded her temperature at different times during 2 consecutive days and found that her lowest temperature is at 7 a.m. when the thermometer showed 97 Fahrenheit. If her highest body temperature was of 99 Fahrenheit, that happened at 12 hours. We need to determine the amplitude, period, and Susan's body temperature at 10 a.m. as well as the sine function. Okay, so we're going to start drawing the sine function. We have here. So we need to identify the points in the sine function. The highest was 99 degrees and the lowest was 97. Okay, so we have of these 2 degrees is 98. For the intervals of the lower part, we have 7 a.m. and 12 a.m. p.m. which is given to us, and like with this we need to identify the half, which is 9:30 a.m. And because the intervals are of 2 hours and a half, we now know that this is 2:30 p.m. And okay, so we need to start with our sine function. So we know that this is the lowest point at 97, and that 12 is our highest point. Okay. So now we know like the basic shape of the sine function starts in the middle and goes like this. So we're gonna draw. Now we have our 5 points, and now we need to know here at 10 a.m. what temperature is the one that's here. Okay, so we need to know the temperature at 10 a.m. So what we're gonna do is we're gonna take the time lapse here is of 5 hours. And we know that in 5 hours, 2 degrees were increased. So 5 hours equals 2 degrees. Because we need to know at 10 a.m., we need to know how much degrees were increased in 1 hour. So this is why we divide 2 degrees in 5 hours. So we know each hour 2 over 5 degrees were increased. If we want to know 10 a.m., we know that 7 and 10 has a difference of 3 hours. So here, 3 hours equals 2 over 5 times 3. So if we put this in our calculator, 2 over 5 times 3 plus 97. Okay. So if we put this on our calculator, we get 98.2 degrees. We can see that here, this makes sense on our sine function because it would be like around here. And as we can see, okay, so now that we have our function, we need to know our equation. So we know that this is the basic sine equation for this function, and we need the amplitude. Okay, so the amplitude is like the difference of each interval, which is 1. So the amplitude will be 1. Next, the b, we need our period, so we can know which our period is 2 pi over b. That is equal to the whole time lapse of our function, which are 10 hours. So we have this equals pi over 5. So this would be our b. Next, our horizontal shift is the difference of like the beginning to the first point that we use, which is 4.5 hours, which would be 4.5. So then our vertical shift would be the point where we start, which is 98. Okay, so now that we have all this information, we need to put it all together to create our sine function. So it would be pi equals sine pi over 5 f minus 4.5 plus 98. So to simplify all this, we put it in the calculator. So we multiply 4.5 times pi over 5, which will give us 9 pi over 10. So our sine function would be sine pi over 5 minus 9 pi over 10 plus 98. So this is our final function. X.
Another real-life application is when doctors use sound wave to determine the amount of heart rate. Like we can see in this picture, you can see a pattern between when it goes down and it goes up. So it goes to the lower part and then to the highest part. So you can see how the equation then just continues and then up and down again, and it does continues repeatedly.
What I reflected individually is that I actually learned what are sine functions and how did they end up being what we know them today. Why do they actually look like they do? I also reflected that it's really important to do my work when we as a team learn, because if I don't do my work, then the person that is going to edit the video cannot do it, and then it's them who are really stressed. So it's really important to work as a team.
In this project, I learned a lot about the applications of sine functions on our daily basis, and I had the opportunity to describe why sine functions are called periodic functions. While doing this research, I could also learn about other questions I had of sine functions.
What I learned thanks to this project is how to work as a team more efficiently, because all of us try to do our work at the same time so we could edit the video and have it on time. Also, this project helped me remember how to graph and build sine functions.
It also taught me some examples of where sine functions can be applied in real life.
This project taught me how to work as a team as well as how to coordinate my time wisely, because I needed to get all my tasks done before the due date. This project also taught me a lot about sine functions because I had forgotten.
I personally think that during this math project, I learned a lot about functions and how we use functions on a daily basis and how we can relate math equations to what we see. Like in some examples, you sometimes see formulas used in real life and you don't understand it or know how to translate what you learn in class to what you do on a daily basis. And I also learned that the functions that we learn during class are really useful, and most of them are, as we can see, used by doctors or used by engineers, architects, and different types of jobs.
In conclusion, we had fun and we learned the applications of sine functions.
And how to apply them on a daily basis.
We also practiced team building abilities and how to work under pressure and how to work on time so the next person can do their job. We could also rely on our team members.
Or as a teacher or something we did in the